I want to go through just a few more examples of the notes from double angles and half angles, and I think both classes maybe ended in just a little bit of a different spot. But I do want to recap example three, just to make sure I have what alpha looks like. And so we remember we had alpha drawn. It is quadrant three, so we come over here, quadrant three. We're labeling alpha. It's a 5, 12, 13 triangle, negative 5, 13, and negative 12. We also have beta as a quadrant 4 angle, and I believe it's a 3, 4, 5 triangle. Yeah, opposite side 4, hypotenuse 5, and this is negative 3. So I think both classes got through A and B. I'll go through C because I don't know if both classes did or not. Um, so if your class did not, pretend you didn't see that. So we're trying to find sine of alpha over 2. And again, use these videos as you see fit. So if you want to try to solve them first and then fast forward and see how you did, awesome. Or follow along, and maybe that's going to help you go through some of these examples as well. So the first thing I'm going to do is apply my formula, half angle of sine, plus or minus. And for sine, it's 1 minus cosine of alpha over 2. And remember, we have to figure out what is it, plus or is it minus? And it's determined by the location of the half angle. Well, remember up here, we drew alpha in quadrants, quadrant 3, because the boundary of alpha was between pi and 3 pi over 2. So we can easily divide that entire inequality statement. There we go. We can divide the entire inequality statement by 2, so we can solve for alpha over 2. So that tells me that pi over 2 is less than alpha over 2, which is less than 3 pi over 4. In other words, it's still in the second quadrant, but it's in the upper half of the second quadrant. And sine, I guess, regardless of where you're at in the second quadrant, sine behaves as a positive ratio. So I know that between the plus and the minus, I'm choosing the plus. And again, I'd like to write it down, plus, and then I go on and continue. So 1 minus the cosine of that angle over 2. And again, scrolling up, what was alpha, cosine's alpha, was negative 12/13. Careful of your negatives. So minus negative 12/13. Oh, there we go. So that becomes a plus 12/13. So I would say 1 divided by 2 is 1/2. And then plus 12/13 divided by 2 would be 12/26. And I just left it like that. I hope that's okay. And you could find your common denominator. 1/2 becomes 13/26 plus those 12/26. So that's the square root of 25/26. Now, when one of those is a perfect square, we definitely want to take the square root. So you could leave it as like 5 over root 26, or you rationalize it as 5 root 26 over 26. And I do remember that one from the hour that we finished. So that would be correct. I remember that. Okay, last one. It's our first one of expanding tangent of 2 beta. So we expanded by saying it's 2 tangent beta divided by 1 minus minus the squared value. So we'll go back. Let's take a look what beta is. Beta was our fourth quadrant angle. The tangent of it would be negative 4/3. So I come down here and I say, okay, that's 2 times negative 4/3 divided by 1 minus negative 4/3 as a quantity squared. Okay, so like the sum and difference of tangent, it gets kind of tricky. You want to be careful. If I multiply 2 times negative 4/3, that's negative 8/3 divided by 1 minus. Now, negative 4/3 as a quantity squared becomes 16/9. Remember, you square both numerator and denominator. And I'm going to do something very similar to what I do when I'm solving the sums and differences. I'm going to multiply by a number, a fancy one, I guess. So in this case, 9 over 9. That's going to clear out my fraction. So I'm going to multiply, multiply, multiply. So when I do that, I end up getting 3 goes into 9 3 times, so that's negative 24. And then 9 times 1 is 9, minus 16. That becomes negative 24 over 9 minus 16 is negative 7, which is 24 sevenths. I'll write that a little bit better. So I hope to write that a little better, 24 sevenths. Okay. So again, just practicing these doubles, practicing these halves. I'm going to go through example 2. And again, up to you. You can pause the video and just solve it and then see what happens and, fast forward to the end. Or follow along, or follow along at double speed. I don't know. So let's first draw what our givens is. Our givens are. So theta, sine ratio is negative 1/3. It exists in quadrant 4. So here's my theta. And its ratio is negative 1 to 3. So Pythagorean theorem reversed gives me root 8 or 2 root 2 positive for the adjacent. And it's just a theta, so off I go. Sine of 2 theta. So that's 2 sine theta times cosine theta. And we look at our ratio. Sine of theta was given to be negative 1/3. Or we can look at our triangle. Cosine theta, 2 root 2 over 3. And then multiply across. So remember the 2 acts as a 2 over 1. And so that simplifies to negative 4 root 2 over 9. Double check. 2 times 2 is 4 root 2. There's the negative over 9. Fantastic. Now, I mentioned in class, there are 3 forms of cosine of 2 theta. You don't have to memorize all of them. You can just stick with maybe the one that makes most sense to you, which for a lot of students, they remember this one the most readily, cosine squared theta minus sine squared. But remember, there's also 2 cosine squared theta minus 1. There's also 1 minus 2 sine squared theta. Does not matter which one you pick. Some students might see, well, I'm given sine of theta, so some students might just naturally gravitate to the one that only involves sine. It's up to you. But seeing as we already drew out the picture, you can use either. So I might do 2 just to show that, it doesn't matter. Like I might do the one that maybe most students would have come up with just because I think that's the first one they remember. So I can look at my value, 2 root 2 over 3 squared is my cosine value, minus sine squared, which is negative 1/3 quantity squared. So that becomes 8/9 minus 1/9, which equals, that was nice, 7/9. Okay, but if you would have used one of the other forms, maybe the one that only involves sine, you would say 1 minus 2 times that negative 1/3 squared, which is 1 minus 2 times 1/9, which is 1 minus 2/9, which is exactly the same as we got before, 7/9. So your choice. Pick what makes most sense, what you can manage, and makes it reasonable for you. Okay, so now we're left with the half angles. Remember our theta initially was between 2 pi and 3 pi over 2. Like that was the given. So dividing by 2, that whole inequality, puts theta in quadrant 2. And we can actually pinpoint which part of quadrant 2, but regardless, it's quadrant 2. Sine behaves as a positive function in quadrant 2, and cosine behaves as a negative. So I'm already kind of laying the groundwork, right, for how I'm going to decide as a plus, as a minus. So I just wanted to, make sure I had that out there. And then we apply the formula. So for sine of theta over 2, remember initially it's plus or minus the square root of 1 minus cosine of theta over 2. And be careful, be neat with your square roots. Make sure it's over the whole expression. Since we know that sine is positive in quadrant 2, I know it's the positive version. And it's 1 minus, what did we say cosine was? 2 root 2 over 3. 2 root 2 over 3. And then make that really big. divided by 2. And I do like to divide those 2's, so that becomes the square root of 1/2 minus 2 root 2 over 6. And then in this case, like I would just maybe make that like a 3 over 6 instead of 1/2. So I can actually simplify. 3 minus 2 root 2 all over 6. And honestly, 6 isn't a perfect square. I'm perfectly happy if this is the way you left your answer. This is perfect. I like that. That's fine. Just be, again, I want to really emphasize that when you're doing your square roots, that it comes all the way down. I don't know if yellow made it worse. I think it did. Let me make it darker. All right, so I'll make that nice square root the whole way. Okay. Last one. We knew that was negative. So initially it would have come out to be plus or minus the square root of 1 plus cosine of theta over 2. And so we already established it was negative. That's the behavior of cosine. It's now 1 plus 2 root 2 over 3, same value as before. Divide by 2. And so then, again, very similar, negative the square root of 1/2 plus 2 root 2 over 3. Now, sorry, 2 root 2 over 6. Now, you could have left it as 2 root 2 over 6, like we did in the previous example, or you could have simplified that to root 2 over 3, since I know that reduces. But I do like to put those in a common denominator. So I'll say it's 3/6 plus 2 root 2 sixths over 6, I guess. So there it is. Okay, so again, the nature and the aesthetic of these half angles don't look as clean, I think, as like that doubles and the half. Or sorry, the doubles and the sums and differences. But you know, doesn't mean we can't solve them. Just be really neat with them. Okay, very good. So again, work through more examples, and hopefully that helps kind of solidify some of those on this page.